Assalamu alaikum. Today our lecture will be from where we left over. As I've mentioned in the last class that we will be studying a little bit of the formation of azorite. So azorite. So let's start our class without further ado. So we have learned about the structure of benzene diazenyl chloride, isn't it? So benzene diazenyl chloride, it looks something like this. So let's say this is our, initially it was like phenyl, this was like phenol, yeah, isn't it? Yeah, it was phenol. When we, initially when it was phenol, when we submerge into it water with heat, it tend to produce this. And also we also need to provide HCl. Wait a minute, let me, just for verification, take a look at the plus note. So that was, oh, sorry. So that was basically phenylamine. My bad. This was actually formation from the phenylamine. So phenylamine towards our benzene diazenyl chloride actually gave the condition for like producing phenol from from benzene diazenyl chloride. So from phenylamine, when we add NaNO2 plus HCl and 5 degrees centigrade, we tend to form or N plus and Cl minus in this case. And like in this structure, when we add further H2O with heat, then phenol is formed. So I somehow gave the answer for like the condition for phenol. I'm really sorry, but that's how it is formed. So now this phenol, this benzene diazenyl chloride, we are going to work with this benzene diazonium chloride. That means only this portion is known as what? The benzene diazonium. Benzene diazonium. Okay, so let's start it. Now we are going to make actually what, as I mentioned, azorite. This benzene diazonium chloride, it reacts with the product it forms from like when heat and water is applied. Okay, so this benzene diazonium chloride is going to react with this phenol in our, like, and produce our required product, in this case azorite. So let's see, this is our benzene diazenyl chloride, benzene ring. Then we have our nitrogen triple bonded with positive charge. In this case, chloride is not important because all we are concerned about only the benzene ion, benzene diazenyl ion. So benzene diazenyl ion plus we have this phenol in this case. Okay, now what is going to happen here? Basically, this reaction is like, I don't have any more space towards the right, so I'm writing it to the like towards the bottom. So when we apply sodium hydroxide in this condition, like when the condition is that's the sodium hydroxide, and these are the two reagents, what happens? This, like one of the bond from here, it breaks. One of the bond from there, it breaks, and it like disappears. Like one of the bond breaks, as well as the charge on the, like, what do I say, the the charge on the, it's like one of the nitrogen, it disappears, forming a neutral substance. So in this case we have now the benzene ring, then we have nitrogen. Now the double bond is formed because one of the bond is broken, and now this nitrogen, it tends to form bond with the other benzene ring without affecting our the phenol structure. Like this OH remains whatever it is, and the other part changes, like the left side, it changes, forming new bond. This is known as azo dye, and its color is orange in color. Orange in color. Okay. So this is our azo dye. Now, there could be other substances over here. Okay, other substances could also be present here, as well as like this portion could also be changed. All we need is this diazonium part and like empty part of the benzene ring, like the part where is no other bond is formed. Okay, that's what we need. So we need this, so the diazonium part and an empty part. Okay, in order to like have this reaction. So let's see a couple of examples. So let's see the second example. We have, let's say, again a benzene diazonium ion and triple bond with, it reacts with, let's say, NR2. Now, what does this NR2 means? Like, it means like, let's say some alkyl group or some other groups are present here. Okay, so it doesn't matter actually what is present there, but that's something is present. Okay, so NR2, that means like some nitrogen substance is also present there, and R, let's say R is for alkyl group. Okay, now again, when the condition is sodium hydroxide, same reaction, same thing is going to happen without affecting anything. So the other things remain same, just this diazonium part, it forms this double bond with nitrogen, and the nitrogen form bond with the other benzene ring, forming this structure. See, nothing remains, like nothing changed. This portion remains same, that portion remains same. Only what changed? The bond. This new bond, it just changed. Okay, so that's our new molecule. This is not azodite. This is something else, but like azodite was this one. This was one specifically azodite. This structure completely, this was azodite. Okay, so like this, like what is azodite? Azodite sometimes it is used as reagents or coloring reagents. That's like that sort of thing. Okay, so one of such reagent is azodite. I've not much idea about like what azodite do, but yeah, that's something. So if we like, let's say in another example, let's say we do have yeah, we do have, let's say, the, the diazonium part, but in the diazonium part, let's change certain things. Let's say we have now this nitro group, okay, NO2 group. So I just wrote in the other way. So if I would have written it over here, this would have been NO2, okay. So like in order to maintain the structure, I wrote it like in the other way, and it's starting from right to left. So when this reacts with, let's say, our this benzene ring, where we have a phenol group as well as, let's say, we have a carboxylic acid here, okay, CO2H or COOH, O2H, okay. Now again, when I apply sodium hydroxide in this case, the product is going to be this one. Okay, before I draw, pause the video, guess what will be the product, draw it yourself, just take the time. Don't worry even if it is wrong. So this is actually the product, N2, and the other portions remain same. See? So now if they ask you in the exam, won't you be able to write it in the exam? So yes, it is like easy to write because now you know actually what happens. Nothing like else change or nothing else matters. Only just this portion is like changed. Now this structure we formed here, this is known as alizarin yellow. These are like not necessary for you to memorize. These are just like for like information to give you. Oftentimes you will see in questions they have written, let's say, alizarin yellow and that sort of things. Okay, don't worry, they're not going to ask you like for structures, like giving the name. They won't ask you that how the structure looks like, or even they won't give you such structures and won't ask you to write the name. They would do nothing. Rather, like I'm just giving the information because you like then makes sense. Okay, so that molecule they're talking about, this is actually that molecule which we studied. Okay, so this is our this part, and what we are with, just a minute, let me see. What else do we have? Okay, so let's do another example where, let's say we have this again a diazonium part. Okay, but this diazonium is now, let's say, bonded with, this is some sulfur, 3 oxygen, and sodium. Okay, so some complex sort of molecule. And on the right side we have now NOH3 2. See, like it doesn't require a phenol to be here. Even if phenol is not present, just if these conditions are present, the reaction still happens. Okay, this reaction still happens. See, there's no phenol towards our right, but still reaction is going to take place, forming our desired structure, or the desired bond is going to be formed, which is N double bond N, and the two benzene structures are like, this is a one benzene structure, that is one benzene structure. They're going to get like bonded with each other, and the other things remain same. So that was CH3 2. This is CH3. CH3 2. And over here we have SO3 Na. This was CH3. Okay, so I forgot, like I mistakenly wrote previously oxygen, so this was like carbon. Okay, so now oftentimes you have heard about the term methyl orange, isn't it? Methyl orange, the indicated methyl orange. We have learned about it in the that was titration. Yeah, in the titration chapter we learned about the methyl orange. At the very like ending part, there was like the reagents information given. So that is the universal indicator. Like we can identify the like what type of solution certain thing is if we place methyl orange into it. If the methyl orange, based on the acidity or alkalinity of the solution, methyl orange will show certain like color. Okay, so this is the methyl orange we used to talk about, methyl orange. This is the structure of the methyl orange. Okay, so that was for this part. Now we'll be moving towards the next topics of our organic chemistry. So our next part is basically polymerism. So polymer. Polymers are we going to learn? So initially we will learn the addition polymer. Addition polymer. So let's define what are addition polymers. Addition polymers are monomers which are like unsaturated. So monomers which are unsaturated. Okay, unsaturated. These are like totally like not saturation. Like they're like, what does saturation means and unsaturation means? Saturation means, for example, if there is a solution in the container, we have a solution. We have, let's say, unsaturated salt solution. That means this solution can dissolve more salt, more sodium chloride could be dissolved. Let's say, okay, that's what unsaturated means. That means like I can give more spoon of salt and still it will dissolve. But saturation means, that means the solution has reached a certain level that now if I give a slight bit of salt, those like even let's say a few tiny bits of particles of salt, those particles won't be dissolving into the like solution, because the solution does not have any more space or scope to dissolve any more sodium chloride. All the water molecules have dissolved the necessary sodium. No, unsaturated and saturated in this case like sort of means the same thing but in a different way. Let's say, like, let me show you in this manner. More atoms or more bonds could be formed. Okay, additional polymer. Addition, what does additional means? It means we are adding something. We are not eliminating something or substituting something. We are adding something. That means if there is this carbon-carbon double bond, one of the bond could be broken And let's say, like if we like add hydrogen here, one of the carbon will be broken and 2 hydrogen will be added. This is what it means, additional polymer, meaning this is unsaturated. That means more bonds could be formed. Okay, but however, if this is the case, that means all the bonds are formed. That means even if we add H2, no more bond will be formed. That means no more addition. That means this is a saturated molecule. But in this case, for forming additional polymerization, we have to, like, the monomers must be unsaturated. Got it? Now, before coming to that, what are polymers? We have detailed description in our O-levels what are polymers, but still let me recap. Polymers are those, if you have, let's say, ethene, you have this ethene, okay? Let's say I have this ethene with me, ethene molecule, okay? So this is my ethene structure. Now, when I apply some, so let's say certain conditions, and I provide, let's say, 5 such ethene molecules, okay? 5 such ethene molecules I have provided, okay? Now, what will happen in addition polymerization is all of, like, one of the single bond will break for each of them, and they are going to form bond with the other molecule. Like this portion will form, like both hand will stretch, isn't it? We'll have 2 hands so that new bonds could be formed because one of the bond is broken. So this carbon's one hand will be on this side, another hand will be this side, isn't it? So because that's how, like, we joined hydrogen previously. So if that's the case, every one of them will have the same, like, manner. They will be forming, like, they will be having hands free. This is known as hands free in the same manner. So if that's the case, that means this carbon now can, like, when this carbon also have this hands free, it can actually, like, shake its hand with this carbon and form the bond. So that means this could be a new structure. Now we have another carbon having free hand. So the next carbon which will be having free hand, that will also come here. Then the next one, and then the next one. I got it? Now, see, here we have repeating units. That means these units are repeating. That means what? These repeating units are known as the monomers. These are the monomers. That means from these monomers, this polymer is formed. Polymer means like large chain of same type of molecule. Large chain of same type of monomer or molecule which repeats itself, forming this sort of thing. For example, polyethylene. You have seen, like, this is the structure of polyethylene. You have initially the ethene, and when you polymerize it, you get the bags, the polythene bags, which we use for, like, groceries, shopping, like other sort of things. So those are the polythene bags made from such polymers. Okay, this can actually, like, not only 5 molecules, this can actually have billions or trillions of like such molecules, and like the chains can continue. Okay, that's why such polythenes are able to, like, we are able to make such polythene bags, like, due to the presence of, like, millions, billions of the or even trillions of these, like, molecules or the monomers. The next point in, like, in defining our polymer is the addition polymer is the monomers. Like here in this case, we have seen, isn't it, the bond breaks, the double bond breaks, and what happens? Like nothing is eliminated, nothing else is eliminated, rather it stretches its hand to the 2 sides and, like, forms bond with other molecules, isn't it? What happens? All of the other, like, tiny monomers, they join up together forming a new big chain, isn't it? A large chain. If we have 5 molecules, 5 monomers, that means what? They add up to form a large polymer, like a single chain polymer. That means what? Is there any additional product formed? No, only a single product is formed. That means no byproduct is formed. Byproduct is formed. That means no, like, no, let's say in a certain reaction we get water as byproduct, or HCl as byproduct, or HBr as byproduct, isn't it? But in this case, no such byproduct is formed. So the third point to define in, like, additional polymerism, that the polymers are what? Saturated. Now, monomers are unsaturated, but polymers are saturated. Polymers are saturated. Now, what does this mean? As I've mentioned earlier, when already all the bonds are, like, broken, like, it does not have any double bond. Okay, That means what? No more addition can happen. That means what? This polymer is already saturated. That means no more polymerization can happen. That's what saturated means. That there is no more double bond present there. That means no more saturation can happen. But if let's say a polymer is formed and let's say this was the condition, this is the like main chain, and these are the like, let's say like these are the like the sub part. This is the actual main chain, okay, and it continues, and there is no more like double bond in the main chain. That means what? The main chain is locked, like this is unsaturated, but these portions, what are those? Those are like, sorry, the main chain is what? Becomes saturated. Why? No more bond could be formed because they have already formed the bond, okay. Let's say up until hydrogen, the bonds have formed. Or let's say this actually formed a ring like structure, like the chain actually formed what? It react with other carbon, like it came whole way around forming this chain, okay. Now that means no more double bond is present in the main chain. That means no more bond could be formed. All the bonds are completely done. But there are certain like atoms in the polymer, those have double bonds. That means what? Those are saturated. I mean, those are unsaturated. Those can still actually participate in like forming bonds. The double bond could be broken, allowing us to have or form like more like complex structures. But when like for simple monomers and simple polymers, after the polymer has been formed, okay, the polymer becomes saturated. That means once the polymers are formed, once this chain is formed, there shouldn't be any more like double bonds present. Because no double bond is present, like we cannot actually make it undergo any further polymerization. That's the like concept. Now the last thing is to consider is the monomers, they can actually arrange in any way to form this such a polymer, okay. So these are actually known as heteropolymer. Heteropolymer. What does this mean? Let's say we have a structure of this pattern. Let's say here is an alkyl group, and here we have hydrogen, hydrogen, hydrogen. Okay, this is our some sort of monomer. Now, when this forms this polymer, what happens? Let's say this is R, and it is not necessary that we have to maintain this repeat unit. Like maintain the structure, we have to R in the second carbon. Not necessary. This can also happen. R can come here, and this can also happen. Okay. This can also like this. They can like interchange their position. Like it can come in this way, and on the other part they can come in the opposite way. But the monomers need to be identical. The monomers has to be the same thing. In this case, it is C2H3, and we have a R group there, or the alkyl group present there. Okay. Now let's see some of the examples. So as I have mentioned already, polythene. So how does polythene actually look like? So polythene has, let's say, n number of such monomers. Okay, so we have n number of C double bond, and we have this hydrogens. So this is our ethene molecule, and when it polymerizes, it forms such type of molecule having hands free. This is a hands free. This is a hand free. Like their hands became free from like the double bond. And how do we represent that? We represent this. This is the repeating unit, and we give bracket towards the end of the repeating unit and place a n here. This means this repeating unit repeats n times. Why? Because we had initially n number of these monomers. That means n number of monomers is going to form this chain, or is going to form bond here. That means this repeating unit repeated itself n times. Now, the n times could be 10, 20, 100, 1,000, million, billion. Yeah. A second example, let's say polypropene. Polypropene. So let's say if polypropene is like initially we have what? Propene, obviously we can like understand from the name. We have to actually guess it from, in this case, from the names. Now propene has a structure of this, and we have n number of molecules. Now when they form polymerization, what happens? Let me draw the repeating unit part of the monomer at first with one single bond in the middle. And we have hydrogen, hydrogen, hydrogen. We have a CH3. hence the hand is free, and we place third brackets and place a n to the bottom. Got it? So that's how we tend to like form the such molecules. Let's say a couple of examples more, which is, let's say, butene. Now, this could be, butene could be actually two types, but 1-ene, but 2-ene. Let's define how. But 1-ene means this is the structure. In butene, what do, like, how many carbons do we have? In butene, we tend to have 4 carbons, isn't it? So one, so if it is but 1-ene, that means the double bond is present between the first and the second carbon. So this should be our structure. This is our but 1-ene. Okay. Now but 2-ene means the double bond is present between the second and the third carbon. Okay. Now you might say, what about but 3-ene? This can also be formed on the third carbon, like this third and fourth. But think it like this way. If we drew it in this way, aren't they mirror image of each other? That means if you see this structure, let's say from the opposite side of the screen, what you would see? You'd see that actually it transformed into this one. So since they are the equal thing, like in this case, if we have counted the carbon from this number, that means what? This is first and second. That means the double bond is in between what? First carbon and the second carbon. So both are identical. Got it? So for polybut 1-ene, we will be having see, yeah, for polybut 1-ene, we have, let's say, initial monomer as butene. But remember, only the carbon chain, like the double bond, you might say that in this case, let's say I'm drawing it in this way. You might say, why didn't I draw this C2H5 like this side? Why not here? Because our main target is what? We have to make hands free of the only double bond. So the main chain only contains which type of molecule? The double, like when the double bonds break, the other carbon, it is going to react with is which one? The other carbons like double bond which broke. So if this was the case, then this is the possible way to form this bond, isn't it? Like these are the hands free of each of them. Like it's the hands how it became free. Now, if I have placed in case C2H5 over here, then what would happen? Then like this would interfere their bond. Like so in order to like make the structure more vivid and like more clearer, I just draw it, okay, in that way, like placing or arranging the C2H5 in such a way that it doesn't hamper my drawing. Now this is C2H5. We have n such molecules. After forming or undergoing polymerization, we have hydrogen C2H5. This is what? Polybut 1-ene. We have the hands are becoming free, and we have say n such type of molecule. This was but 1-ene. What about but 2-ene? So but 2-ene would be polybut 2-ene. This is gonna be, we have hydrogen, and but 2-ene looks how does it look? We have seen that it is between the second and third carbon. So we have a CH2 towards the left and a CH2 towards the right. Okay, there are n such molecule, and after forming the polymerization, we have CH3 hydrogen. Even if you give the CH3 on the top, one of them on the top, or both of them on the top side, it's completely fine. Like all are correct. So there we have n such molecules. Okay, now coming to the next part, we could have, let's say, like showing a few more examples. Let's say we have polyvinyl chloride. Polyvinyl chloride. Okay, this is known as PVC. The PVC pipes we tend to use. Okay, so this is the structure. C bonded with hydrogen, and there is going to be a chlorine. That means what? It is actually like chloromethane. We have a chlorine and a methane, sorry, ethene, chloroethene. I'm really sorry. This is chloroethene. So when this actually undergoes such polymerization reaction, what happens? And everything remains same, this hydrogen, 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 and the hands became free. We have n such molecules. Let's see a couple of more such examples in order to understand how polymerization like structure takes place. So polytetrafluoroethene. This is known as also Teflon. The short form is Teflon. So we have, let's say, this fluorine. Tetrafluoro means we have 4 fluorine. That's what the name suggests. And if n such molecule is present, what do we have? The hands became free, the bond breaks, and we have carbon forming bonds. And the repeating unit is just shown as like the third bracket or the square brackets to the either side, and placing n at the bottom, showing that n such monomers or n such repeating units are present. Then we have polystyrene or polystyrene. Now, how this structure looks like? This is an interesting structure, which is one of the carbon has a benzene structure. But don't worry, benzene won't get like this, nothing will happen to the benzene ring. So this is the structure, and such molecules or monomer is present. And when the hands become free, we have this part with 6 bonds or 6 like hexagonal structure, and we have n such molecule. Okay, so this is the mixed structure. Everything remains same, just the double bond breaks. In every of the cases, just the double bond breaks. Lastly, we have polypropanoic acid. Okay, now how does it look like? The part here, it means propanoic acid. That means let's draw at first the propanoic acid, which is C, like CH2, then CHCOOH, which is in this way it looks like. And we have n such molecule. From here, like propan means what? We have 3 carbons. So that means if we draw the simple the alkane, we have 3 carbons. Now, in terms of propene or propanoic acid, so this is propenoic, yeah, propenoic, not propanoic. This is propene, E. That means an alkene is present. Now, propene has a structure of what? This is the structure of propene. Now, when it has a carboxylic acid, that means what? This is going to be the structure in this case, isn't it? So this is our propanoic acid. So when this reacts, the double bond breaks. COH, and we have hydrogen, 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 and the hands-free part showing the n number of such molecules. Okay, so this is actually our structure. Now let's identify certain monomers, or let's see what the polymers look like in examples. So let's say these are some examples given polymers. Let's say, yeah. So let's say we have CNH, CH2. I would urge you to like do the structures by yourself, like try it by yourself, like based on the knowledge you just learned, and try to identify which are the repeating units in this case. Okay, like what do you think which would be the repeating units? So let's say this is the structure given, this is the monomer actually given, and you need to identify what are the 2 monomers, or what are the 3 monomers, or how many monomers are present and what are they. So this is one of them. The second one is, let's say, COCH, and we have from here CH2. This is CH2. This is CH3. Oxygen, CO, CH, CH2, oxygen, CH3. This one also like the same way you should find. And in this case also the same way. Before solving, okay, never mind. Acha, before solving this, we would do some other thing. I would like, I won't be asking you to solve it right now. because we will be solving it just after a few minutes, because we have some other part as well, because in order to solve this, we need some other knowledge also. And then we have CH2 here, CH there, CONH2. We have CH2 here, and this part continues. Okay, so yeah, before going to that, let's start, or I'll be giving you this as a homework to identify them. So before solving the 3 questions, we'll be having also understanding what is condensation polymerization. Since additional polymerization means what? It means we are adding something and getting something, like getting a product. Condensation means it is going to be condensed. Now, when water condenses, what happens? It forms, like the water vapor condenses, what does it form? It forms water droplets, isn't it? Similarly, when this condenses, a tiny bit of particle or a tiny substance will be eliminated. In this case, it will be water, it could be HCl, anything, okay? So what are these? These are monomers having different functional group. So monomers have different functional group. For additional polymer, what did you see? Like same molecule actually formed them, isn't it? But in condensation polymerization, they can have like different functional group. That means one could be polythene, another could be other